Okay, so this weekly quiz will actually make up part 3 of your Test 2 review packet, but we will have another weekly quiz this Friday, so you'll actually have 4 parts to your Test 2 review packet before your test, which is not this Thursday, but next Thursday. And that is the last day of the quarter. You usually don't have to submit grades for the following Wednesday. So there's plenty of time. Okay, so let's go through each of these problems in detail. Number 1, what do we do first? Add 8, so you're going to get 2 times e to the 2x minus 1 equals 8. What do we do next? Divide by 2, so you get e to the 2x minus 1 equals 4. I saw a lot of people like taking this 2 and multiplying it through that exponent. Is 2 times 3 squared the same thing as 3 to the 4th? No. 2 times 3 squared is 18. 3 to the 4th is 81. Those are not the same. So there's no rule that tells you a number being multiplied in front of an exponential can go up into the exponent of that exponential. So, again, and I tried warning everybody ahead of time, the biggest mistakes we make are making up rules. So I saw a lot of made-up rules. That happens. The big thing is, logarithms are really when, and I know we think order of operations is this easy concept. We think, oh, functions are easy. It is not understanding PEMDAS and functions deeply enough that causes most of the mistakes in this section. It really is. To really overthink deeply about PEMDAS. Really analyze how it works. What's the next thing we do to both sides? Natural log both sides. That was loud. So we are going to have 2x minus 1 equals natural log 4. Add a 1 to both sides. A lot of people wrote natural log 4 minus 1. It is natural log 4 plus 1. And then what do we do to both sides? And you're dividing the entire side by 2. So it looks like this, of which you can write that as natural log 4 over 2 plus 1/2. Okay, a lot of people just did natural log 4 over 2 minus 1 or plus 1. It's plus 1/2. And so if you type that in your calculator, you should get 1.193. Bam. Okay. Any questions on number 1? Yes, ma'am.
This is not for number 1, but are we going to give some of our graph and calculators?
Yeah, maybe. I don't know. Probably. On this stuff. I mean, if I let you have your graph and calculator on the quiz, I'll let you have it on the saved problems on the test.
Well, the one that we did, like, half and half on, you said that we're allowed to use it on that one, right? Yeah,
because you showed me that you know it. Now, this one, I don't know. Maybe we'll regress after this quiz. Maybe come test time I should make you do these without a calculator, because this quiz is pretty ugly. On this quiz? Well, this class did, but yeah. It's still a low averaging quiz for this class, though.
Generally speaking, what's the average of averages?
Average of averages?
Yeah.
Well, I don't know. Okay, let's look at number 2. Condensing. Condensing, you basically want to go in order of operations. Like if you were, besides the actual evaluation of the logarithms, you want to do the multiplications first, then the additions. So each of these multiplications, this 1/2, becomes the exponent of this 9. So this becomes log base 2 of 9 to the 1/2 power. A lot of people wrote that as 9 to the second, or negative second, or negative first. I don't know why that number, which is a 1/2 in front of the logarithm, would be changing when it goes into the exponent. The rule says whatever number's in front becomes the exponent. So this becomes log base 2 of 9 to the 1/2 power. This 2 also becomes an exponent. So we can call this the log base 2 of x squared. Some people notice, hey, these two here are actually like terms, and they just combine like terms. That also works. It's probably easier, actually. Next, Additions and subtractions go from left to right, so let's condense them. And what is 9 raised to the 1/2 power? It's 3. So you end up with the log base 2 of 3 times x squared minus the log base 2 of x. And then that becomes a division. So you have the log base 2 of 3x squared over x, of which that simplifies down to just log base 2 of 3x. So that's your final answer for number 2.
When you're also taking the -1 in front of log base 2 of x, which multiplied it into the exponent.
Yeah, so you could have solved this plus log base 2 of x to the negative first, like that, and then actually multiplied, of which you would have added these exponents, and yeah, that also could have been done. Absolutely. Then we go on to number 3, and what I hoped you would notice, though it wasn't important, was, hey, the left side of this equation is number 2, right? The funny thing was, a lot of people didn't notice, they got different answers. Like number 2, there's somebody that did number 2 wrong, but actually condensed the left side of number 3 correctly. It's pretty wild. Okay? So when you solve this equation, you want to condense the left side first. So this equation should become the log base 2 of 3x equals 5. Right? Because the same condensing from number 2 should have happened.
Can we just do that so that's right first step?
Yeah. In fact, some people got 2 wrong, but did that, and I didn't take off for it. I graded what they had anyway. I figured, I don't want to take points off for number 3 that really was points I already took off for you from number 2. But that wasn't fair. Yeah. So, you should, after condensing the left side of number 2, gotten the log base 2 of 3x equals 5. So we exponentiate both sides. So this becomes 2 raised to the log base 2 of 3x power equals 2 to the 5th. Some people are raising 5 to the 2nd power. No, it's 2 to the 5th power. So you get 3x equals 32. So your final answer is 32/3. Agreed? I don't think we need to go over number 4 because that was pretty easy. I'm just teasing. Okay, I was really impressed. Somebody solved number 4. I think they were in my 5th period class, 5th or 6th period. And they solved number 4 using a method I had never even thought of, and it turned out to be probably the easiest method. It was genius. I loved it. So here's what they did. They took 2 to the x plus 1, and they rewrote it as 2 to the x times 2 to the 1st. Okay? Then they divided both sides by 2 to the x. So you have 2 equals 3 to the x divided by 2 to the x, right? And they're like, hey, see how those exponents are the same? They're both x? I'm just going to call that 3/2 to the x. And now I'm just going to take a log base 3/2 of both sides. And that's it. You're done. The answer is the log base 3/2 of 2. Which, if you type that in your calculator, you get 1.710.
What's that?
I can't remember. I honestly can't remember. I'm like, really slick? I saw the work and I was like, wow, why did you do it? I took a log of both sides. I made it gross. Here's what I did. I took a natural log of both sides. So I had natural